My name is Rebecca Dirkes, and I am a PhD candidate in nutritional sciences here at the University of Missouri in the Department of Nutrition and Exercise Physiology, and I work under Dr. Pamela Brzezina. So our main research focus is skeletal health and skeletal development. We primarily focus on bones, and we primarily use rodent models to explore different relationships between nutrition and hormones and bone. And so my main dissertation project relates to gestational exposure to bisphenol molecules and skeletal development. And so bisphenols are molecules found in plastics. They are endocrine disruptors and estrogen receptor modulators, so they can bind to the estrogen receptor and block normal estrogen signaling. And estrogen is very important for bone development in both males and females, and so we wanted to explore the possible impacts of this blocking of normal estrogen signaling during uterine development. So we took female mice and we randomized them into 3 different groups. We had BPA exposure, BPS exposure, which are just 2 different analogs of bisphenol analogs, and then our control animals. We mated them to the males, and then we took 1 male and 1 female offspring from each dam, and so we had those 3 different exposure groups, and we tracked them into adulthood, the offspring. And so keeping in mind that the offspring were only exposed during uterine development, so during gestation, and then during lactation, and after weaning they should not have been exposed to BPA or BPS at all. And we found that in adulthood, the female animals were fine. There was pretty much no negative or positive impacts of bisphenol A exposure or S. The exposed animals pretty much matched the control animals. However, in the male offspring, there was a significant severe negative impacts of BPA exposure on skeletal development. So they had smaller bones and they had thinner bones and just less overall bone material. Interesting, this was only in the BPA animals and not in the BPS animals, which would indicate some differences between those 2 analogs. And it's also interesting that it was only in the males and not in the females. So this could partially be related to just overall estrogen availability. Males tend to produce less estrogen than females, and so if they had BPA, it could have been more of a blocking than in the females, but this is definitely worth exploring further, especially if this could also be shown to be true in humans, because this would be something that pregnant women would really want to be aware of and want to watch out for, especially if they're having boys.